everyone, welcome back. So now what we're going to do is look at some application problems so we can see how to actually apply all of the things that we've been learning. The best thing to do when working on application problems is always draw a picture, so that way you can get your triangle in that picture. So the first problem we're going to look at is consider a person standing 12 feet from a light pole. The individual notices that the light casts a shadow of his body that is 5 feet long. If the individual is 5 feet 6 inches tall, how tall is the light pole? Okay, so let's go ahead and draw our picture. So we're going to start with our light pole. And we're going to imagine that that light is shining down on the street. And we know that there's going to be a person that is 12 feet away. And then it's creating a shadow that is 5 feet. Okay, and you can see here that we end up with kind of two triangles. We have this bigger triangle, and then we have a smaller triangle. Okay, we also know that the individual is 5 feet 6 inches tall, so that means that we're going to go ahead and label the person as 5.5, because remember 6 inches is 6 out of 12. Which is the 0.5. And then the question is, how tall is the light pole? So that is going to be our variable, that is going to be our x. Okay, so we first have created our diagram. We're going to label all the things, which we did. So now for part B, we want to determine the height of the light pole and then justify our solution. So there's actually two different ways that we can solve this problem. Typically what I do in class is I ask the students just to try this on their own and see which solution they come up with. So I'm going to encourage you to do the same thing. So go ahead and pause the video and try to come up with a way to solve this problem. Okay, if you need a hint, if you look at part C, it says determine an alternative method to determine the height of the light pole. So if you used the inverse trig functions, then they want you to use similar triangles and vice versa. So if you need a hint, those are your two hints. So use the inverse of a trig function or use similar triangles. So again, pause the video and try this problem on your own. All right, so the two ways that we can solve this, let's first start with our trig functions. So when we look at our triangles, what I'm going to do is draw kind of the two separate triangles. So the bigger triangle, we have one side is 17, and then this side is the x. And then the smaller triangle, we have 5.5 for the height of the person, and then 5 feet for the shadow. So one of the things that both triangles have in common is this angle down here. And so when we look at what values we are given from that angle, we have the hypotenuse and the adjacent on both of those. Notice we are not given the hypotenuse. I have found some students will find the hypotenuse of that smaller triangle, and that's absolutely fine, which then means you can use the sine or the cosine function. But with this, because we are given the opposite and the adjacent, let's go ahead and use the tangent function, right? And the reason for that is, remember, tangent is TOA, so that's going to be the opposite over the adjacent. So tangent of theta is equal to 5.5 over the adjacent of 5 for the smaller triangle. Then what we can do is find the inverse of this tangent function. So tangent inverse of 5.5 divided by 5, which gives us a theta of 0.833 radians. Okay, now that we have that angle measure from the smaller triangle, we can now apply that angle to this larger triangle of 0.833. So we can continue using that tangent function, But this time on that larger triangle, we know the angle is 0.833 equals the opposite, which is our unknown, over 17, which is the adjacent. Okay, when we go to solve this, we can multiply both sides by 17. So then the 17s on the right-hand side cancel, leaving us with just x by itself. And then here we get 17 tangent of 0.833. And then we can go ahead and plug all of that into the calculator. When we do that, we get 18.7. So that means that the light pole is 18.7 feet tall. Alternatively, if you are looking at similar triangles, that also works. Okay, so again, we have our two triangles. The bigger triangle, we have a height of x, and then a horizontal distance of 17. The smaller triangle, we have 5.5 and 5. Okay, with similar triangles, we could set it up as a ratio of 5.5 over 5, so we take the ratio of the sides of one triangle, set it equal to the ratios of the sides of the other triangle. So we get x over 17. Just remember to keep the ideas the same. So in the numerator, we're using the vertical height on both of those, and then in the denominator, we're using that horizontal distance. Okay, once we have our similar triangles, then we can go ahead and do that cross multiplication. So we get 5.5 times 17 is equal to 5 times x. The left side gives us 93.5 is equal to 5x, and then divide both sides by 5. And we will again get the 18.7, which means that our light pole is 18.7 feet tall. The reason why similar triangles work is because of our trig. Notice that in both of the problems, we had our tangent theta equal to opposite over adjacent. So if we look back at the work on the first part, we have 5.5 over 5 is equal to x over 17. And that is just taking the tangent of theta. They are both equal to those fractions. So that is why similar triangles work, is because of the trig behind it. All right, we will continue this worksheet in the next video.